As we move on to section 11.5, 11.5 you're going to be adding and subtracting those fractions that have all that factoring in it, but you're actually going to be able to get rid of the fractions and clear them out today, so I think you'll enjoy that part. So the directions say that we're going to be solving rational equations. You guys, today you're going to see a big equal sign. You're going to be really happy, hopefully, that you see an equal sign because that means that the fractions are going to go away. So today we're going to go back to chapter 11 and factoring. And more specifically, I want you to write down, it's called rational expressions. Okay, so we're going to have fractions that have x's in them. The nice thing about today, though, is that there is going to be an equal sign. Because there's going to be an equal sign, two things happen. You are going to get an answer for x. Your answer won't be those crazy things we were getting in 11-4. You'll actually get like 1 or 2 or 5 or 10. And you will get to eliminate the fractions, or the denominators, the fractions, whatever you want to say. But they will go away, unlike 11-4 in which they stayed to haunt you. You still need to, as we move on to section 11.5, 11.5 you're going to be adding and subtracting those fractions that have all that factoring in it, but you're actually going to be able to get rid of the fractions and clear them out today, so I think you'll enjoy that part. So the directions say that we're going to be solving rational equations. You guys, today you're going to see a big equal sign. You're going to be really happy, hopefully, that you see an equal sign because that means that the fractions are going to go away. So today we're going to go back to chapter 11 and factoring. And more specifically, I want you to write down, it's called rational expressions. Okay, so we're going to have fractions that have x's in them. The nice thing about today, though, is that there is going to be an equal sign. Because there's going to be an equal sign, two things happen. You are going to get an answer for x. Your answer won't be those crazy things we were getting in 11-4. You'll actually get like 1 or 2 or 5 or 10. And you will get to eliminate the fractions, or the denominators, the fractions, whatever you want to say. But they will go away, unlike 11-4 in which they stayed to haunt you. You still need to factor the denominators and decide what the new common denominator would be. And what each numerator will need. Like, you'll have to decide, like, oh, this numerator is missing this denominator, or vice versa, okay? Before we move on, we do have to make sure that you remember this. When you just have to solve for, like, x, like you don't see x squared, there's really only going to be one answer. Take the x's to one side, take the constants to the other, and solve for x by dividing. So if you get, like, 3x equals 5 plus 2x, that's what I'm talking about. You would take away 2x, you would get 1x equals 5, you would divide by 1, and x equals 5. Please pause the video if I did that too fast so you can keep up. On the other hand, if you're solving for x squared, it's possible to have two answers. So remember, when you have an x squared, guys, I hope you remember this from chapter 9, you have to set it equal to 0, take everything to one side. You are going to use the quadratic formula. Do you guys remember a negative b, plus or minus, that thing? Or you can do factoring with boxes and solve. Okay? So if you see something like x squared plus 5x, let's do plus 6 equals 0, that's what I mean. You're going to have to do the quadratic formula or the box there. And really, you guys are probably really, really good at the boxes right now because you need to be for this particular section. All right, problem 1. Look at the bottoms here. Aren't this really nice? These denominators are monomials. I'm just going to write monomials like that, mono. So they will not factor. You should be very happy that those are not going to factor. So the common denominator will be, let's put a big pair of parentheses around those. I'm going to say it's going to be 10, because all those 5s and 2s, 10 goes into them. and each one has a maximum of x. So the common denominator is going to be 10 and x. So now we're going to go back through and see what's missing. This 2, for the 5x to become a 10x, you need to multiply by another 2. For this 1, to get 2x into 10x, you need to multiply by 5. And this 1, in order to get this 1, or I'm sorry, in order to get this 2 into a 10x, in order to get my left hand to match my right hand, you need a 5x. So you're trying to figure out, what do I need here, here, and here, and that's how I got my 2, my 5, and my 5x. Now let's put those things together. The first circle, 2 times 2 is 4. Then I bring my minus sign down. 5 times 1 is 5. Then I bring my equal sign down. Then I bring my negative sign down. 5x times 1 is 5x. Guys, the denominators are gone because there's an equal sign. It's almost like we're canceling out the denominator, which makes it a beautiful math problem. I only see a regular old x. I don't have to do the quadratic formula. 4 minus 5 is negative 1 equals negative 5x. And now it's just basic solving. Divide by negative 5. Negative 1 divided by negative 5 is either 0.2 or positive 1/5. Whatever you want as an answer. Let's try that 2 more times. Again, notice this entire page is made up of monomials in the denominators, okay? That makes these problems a little bit easier than some that are coming. What we're going to do is we're going to put a big set of parentheses around each one, okay? The common denominator up here is just a 3 and an x. It's not 3x squared, it's just 3 and x, because none of these are x squared. Let's go and see what the bottoms are missing. Now, I'm a color coding person. You might want to go grab a color pencil if you like the way that I'm doing my lesson. My left finger to my right finger. The only thing that's missing is, hopefully you're saying, an x. My left finger to my right finger. The only thing that's missing, hopefully you say, is a 3. My left finger to my right finger, the only thing that's missing is a 3. Now let's carry things down. X times 1 is 1x. I'm going to carry it over. Plus 3 times 3 is 9. Equals 3 times 2 is 6. Look at this basic math problem we have now. We've canceled our denominators because of that equal sign. So we have to take away 9, just basic algebra. 1x equals negative 3. Divide by 1, x is negative 3. All right, let's try that one more time. Let's see if you can get your common denominator. 7x, 3, and 3x. Why don't you try it? And then I'll count to like 10 in my head, and you try writing down what you think the common denominator is, and we'll see if we match. All right. Well, with the 7 and the 3's, I'm going to pick 21, because they both go into 21. I really just multiply them together. And it's just a single x. You might think x squared, but these ones aren't squared, so you're not going to bring over a squared. Now let's see what's missing. So I'm going to draw my really big circles. And I'm going to count to 10 again. Why don't you guys see if you can figure out how to make my left finger match my right finger. All right, to get 7x into 21x, you need just a 3. Okay, now this one. To get 3 into 21x, you need a 7x. It's almost, you're really just dividing, essentially, is what's happening. And to get 3x into 21x, you need just a 7. Okay? So if you were like to check, you could be like, okay, this 3 and this 7x, yep. That 7x and that 3 makes 21x, yep. And that 7 and that 3x makes 21x. Now put them together. This makes 12, 4 times 3, a plus sign, that makes 7x, an equal sign, and that makes 49. Basic Algebra 1 problem. We're going to take away 12. 7x equals 37. And we're going to divide by 7. It does not reduce, and you know I hate decimals. So 37 over 7. All right, it's going to get harder now, okay? These are monomials again. So we're not going to be able to factor the denominators. That should make you pretty happy right now. Put parentheses around them. The common denominator is going to be, I may as well throw this one under 1, or over 1. I hope you see the common denominator, just kind of looking at all these, is an x squared. Now it's not just x, because this one has a squared, we need a squared at the end. Let's see what's missing. Alright, here we go. My left hand to my right hand is missing an x squared. I guess I was using my orange marker there. Okay, my left hand into my right hand is missing an x. And my left hand into my right hand again isn't missing a darn thing. It's good. Give it a little check mark. Multiply. That makes 1x squared minus 2x equals 8. Alright guys, I've got an x squared. And if you remember, when I have an x squared, I have to use I have to set it equal to 0. I have to use a quadratic formula or the box. Okay, so we're going to take this 8 to the other side. So 1x squared minus 2x minus 8 equals 0. We have to do a minus 8 to move it over, equals 0. I like to factor. I don't know if you guys want to use the quadratic formula, whatever you want. Honestly, you guys are really, really good now at this box thing. So I would do a times c is -8, b is -2. My magic numbers, therefore, are -4 and 2. And the box is going to be, put your x squared in here, put your -8 in there, put your -4x and your 2x. You should be really good at this right now, especially after taking those keystones. You reviewed a lot of factoring. Pull out an x, pull out a 2, pull out an x, pull out a -4. Again, you guys should be pretty darn good at this. And we have x minus 4 and x plus 2. If you do not like what I'm doing, just do the quadratic formula, okay? You'll get the same answers I am. Set this one equal to 0. Set this one equal to 0. Solve for x by adding 4. Solve for x by subtracting 2. And look at that. We've got 2 beautiful answers. Notice I haven't been doing the checks. I'm going to do that on a later video. Number 2. All right, now we're stepping it up a level. Look at your denominator over here. This time I do have a binomial. Do you see it in the denominator? All right, it's not going to be that hard, I promise. You know this is over 1. You know this is over 1. So let's try to figure out our common denominator. Who cares about these 1s? They're not important. The common denominator is d plus 3. And we can put our force field around it if you want. Alright, now let's go through and see what's missing. So here's one numerator, here's another numerator, and here's another numerator. For my left hand to be my right hand, I am missing an entire d plus 3 force field. From my left hand to my right hand, I am missing an entire d plus 3. Use that force field. From my left hand to my right hand, I am missing absolutely nothing. Alright, let's go ahead and carry stuff down. So we're going to carry that d down and the force field d plus 3. So there I go. I carried that circle down. Then a big plus sign. I'm going to carry the 6 down and my force field to d plus 3. So I carried my second circle down, guys. And there's my equal sign. I'm going to carry this entire circle down, d plus 11. It didn't need anything, so I don't need to put its force field on. Alright, now I need to distribute. So when I distribute in, I get d squared plus 3d plus 6d plus 18 equals d plus 11. Now I need to combine my like terms. That's d squared plus 9d plus 18 equals d plus 11. Now I need to set it equal to 0. So I need to minus this 1d and minus this So when we move these things to the other side, we get d squared plus 8d plus 7 equals 0. Now it is your turn. Do you want to factor or do you want to use the quadratic formula? You guys are pretty good at factoring. So what I would do if I were you, if you wanted to be a responsible young student, pause the video, put this in a box, and factor it. You should get d plus 1 and d plus 7. Now you set each of those equal to 0. D plus 1 equals 0, d plus 7 equals 0. Take away 1, so you get d equals, let's see, take away 1, d equals negative 1, take away 7, d equals negative 7. And we will check this in another video.